Can the air conditioning system where you work or in your child's school help stop the spread of the SARS-CoV-2 virus and COVID-19? Let's meet an engineer who says there are things schools and businesses can and probably should be doing to help make the air safer for everyone. I'm Lee Kelso, health correspondent, and this is HealthCall Live Online, the place for extended versions of interviews featured in a weekly radio broadcast and podcast. It is now widely accepted that COVID-19 can be spread through airborne particles so small they can drift around in the air for quite a while. The American Society of Heating, Refrigerating, and Air Conditioning Engineers has created a task force to help schools protect kids from exposure, steps that can also be used in your workplace. So let's meet Corey Metzger. He is the team lead on that task force. Corey, thanks for joining us.
Thanks for having me.
How much can these steps reduce the risk of aerial spread of the COVID virus?
That's a really great question. We're not in a position to be able to specifically quantify that reduction right now, just given the lack of scientific data that we've got. There is significant data available, but a lot to be learned yet. So that being said, we know that we can significantly reduce concentrations of airborne contaminants, including viral particles, using strategies such as ventilation, filtration, potentially humidification or others. And we also need to look at air distribution in spaces. We certainly want to be clear up front that while we are fairly certain that airborne transmission is occurring from aerosolized particles, we still think that the most prevalent form of transmission is close contact, person to person, whether physical or close transmission of respiratory droplets. So all of the steps that we're looking at, while critically important, should be combined with other steps such as social distancing, appropriate PPE or face coverings, that sort of thing.
Yeah, I get it. So don't slack off and count on changes in air handling to do the job for you, right?
Exactly.
So you mentioned some of the strategies your group is engaging in. So let's start with the dilution of the virus in circulation. So more fresh air. Is that just as easy as opening the window?
Yeah, that's a great question. So building mechanical systems or HVAC systems generally should be designed with ventilation air included. So current standards, depending on space type, will require different amounts, but it's generally based on the number of people in the space and the size of the space. If you have properly operating systems to cover those needs, that should provide a good baseline for removing contaminants from space, airborne contaminants from space.
Now, I've heard, Corey, that and have read that buildings today, the HVAC systems are smart enough so that when it's hot and humid outside, they take in less fresh air. Is that something that you can adjust? Is that something we need to change?
Sure. Yeah, and in fact, we've suggested that. So what you're referring to is generally called demand-controlled ventilation. What we've done for years, our organization, ASHRAE, is focused on good indoor air quality, but also energy conservation and making buildings more sustainable. So we're trying to accomplish multiple things at the same time. One of the strategies that we've used to do that is called demand-controlled ventilation. So basically trying to reduce the amount of outside air that's brought into a building through the mechanical systems when it's not needed. That's generally done using carbon dioxide as a surrogate for occupancy. There are some other ways that can be done as well. We recommend in the guidance that's been issued that wherever feasible, demand-controlled ventilation either be disabled or set points be adjusted so that more outdoor air is brought in, and that we're not advocating against saving energy, but the health and well-being of the occupants is our first priority, right?
So is that something that should already have been done? Do I need to talk to my HVAC company about that? How can I be sure that I'm getting as much fresh air as I need in the building?
That's a great question. There are a couple of steps, and it depends a little bit on your building systems. But we certainly recommend talking to whoever's maintaining or operating the building and going through that. In the guidance that we've issued, we've also recommended going back and checking and making sure that your systems are working the way that they're supposed to. The reality is many systems that have been installed, sometimes even new systems, don't work quite the way that they're supposed to. So we want to make sure that sensors are calibrated and working properly, that actuators on dampers or valves are opening and closing the way that they should be, that if there's airflow measurement occurring, those sensors are calibrated as well, so that we don't just assume. What happens frequently is a system may control temperature effectively in a space, so we just assume that it's working, right? And when there's not a global pandemic, unfortunately, a lot of times we don't pay much attention to what's happening with indoor air quality. This has really shined a spotlight on that need to consider whether those systems are doing more than just controlling temperature in the space.
A lot of modern buildings are essentially sealed up, very few windows and whatnot because of the energy savings you just talked about. What should building managers be doing if that's your situation to make even more fresh air available outside what we've already discussed?
Yeah, so we've certainly, almost all modern systems should have outdoor air capabilities to bring ventilation air into the building. We're recommending looking at system capacities to see if additional outside air can be brought in effectively. Now, there are a few things we want to make sure of. One of the key things, though, is that we can still maintain temperature and humidity control. So we don't want to give up the ability to maintain an otherwise healthy indoor environment by bringing in excess outside air. As we do that, cooling coils that were designed for a certain amount of outside air may begin to have problems controlling temperature and humidity in the space. Humidity is probably the bigger of the two concerns. If the temperature climbs a few degrees, most occupants, you may have some comfort complaints, but it probably won't stress them in a meaningful way. Humidity, on the other hand, at elevated conditions can start to be absorbed into building surfaces, and over time we can see mold growth. Want to add other potential airborne pathogens or contaminants that could exacerbate problems for an airborne infection that's attacking the lungs.
At the same time, I have read that increased humidity levels actually help fight the virus. The virus does not do as well in higher humidities. So I get it. You've got kind of a knife edge. You've got a balance there, making people comfortable, keeping the building mold-free, yet humidity as high as possible for the virus. What's your recommendation levels?
Yeah, that's a great question. Our recommendations on that are based on some studies that were done on influenza A as an airborne transmission pathway for influenza A. What those studies show is that just over 40% is the lowest transmission rate for that airborne transmission pathway for influenza A. We're assuming that a similar result would occur for SARS-CoV-2. The reason for that is that the reduction appears to be due to that higher relative humidity level preventing those respiratory droplets from evaporating as quickly and potentially leaving small particles that remain aerosolized or airborne for extended periods of time. What we have in much of the U.S., not the entire country, because there are some areas that are much drier. If you think about high arid desert or desert areas, the West Coast may have less of a chance here. But if you move to the eastern half of the country, most areas, when they're in the cooling season, don't have any trouble maintaining a minimum humidity level. 40% isn't hard to achieve. We're really trying to keep it below 50%. 50 to 60% is where we want to be to prevent mold growth during those times. The cooling season is less of a challenge really than the heating season for good portions of the country. There are areas where it's dry enough that may be a concern, and there may be humidification considered during the cooling season.
So we might need to be boosting our humidity levels in the winter. Yeah, that makes sense. Yeah.
Now, any of our strategies need to be considered carefully. So when you think about humidification, it can be potentially a great strategy. There are a few things from those studies. I don't believe that they include any consideration for social distancing or facial coverings. So there's likelihood that drop off that occurs in those studies may be impacted. with those steps in place. The other consideration is adding humidification to a building that wasn't designed for it in the envelope could again create condensation issues and potential for mold growth or other indoor air quality problems. As with any strategy, it needs to be considered carefully before being implemented.
Okay, makes sense. So another recommendation you have is specialized filters and adding those to your heating and air conditioning systems. Tell me more about these filters. How much virus can they actually eliminate?
Sure. So in most commercial buildings, we likely would expect to find filters are rated with a MERV rating or minimum efficiency reporting value rating. That is based on ASHRAE standard 52.2. So most commercial buildings probably have MERV ratings for their filters in the 6 to 8 range. We have recommended targeting a minimum of a MERV 13 filter, preferably MERV 14 if that can be achieved.
Let me stop you there. So what you're saying is that I need a filter that can remove smaller particles than might typically be installed today, right? I need a more refined filter, a 13 or a 14 did I hear you recommend. So what's the challenge in doing that? Can I just drop that into any heating and air conditioning system?
That's a great question. So the answer is likely no. Not any system. They need to, again, be looked at because these higher efficiency filters, depending on the technology that's used to achieve that removal effectiveness, have additional pressure drop associated with them. So they may reduce the amount of airflow that the unit that they're serving can provide. And so if we reduce air distribution effectiveness in a space or reduce the amount of airflow that is being delivered that may include that ventilation air we're talking about to dilute the potential contaminants in the space, that may actually be counterproductive. There are different filter technologies. Some filters use an electrostatic charge to improve their effectiveness.
So is it your expectation that can you generalize and say that the average school system can handle the filter upgrade, or how would they know?
It depends significantly on systems. So one of the things we look at with schools is there is a huge variety of HVAC systems that serve buildings, everything from buildings that have no ventilation and steam radiators to newer buildings that might have central dedicated outside air systems with terminal equipment to buildings that have central variable volume air handlers. The reality is, I think most school districts around the country have been focused on, and I don't mean to take anything away from them in saying this, but they've been focused on cleaning surfaces and focused on how to maybe check occupants of the building when they arrive. The World Health Organization, the CDC, other groups initially were focused entirely on close contact transmission and not on airborne or aerosolized transmission. So I'm not sure if you're familiar, there was a letter sent to the WHO back on or around July 4th, 39 scientists.
Yeah, I am familiar with that. The WHO was late to the game. I mean, it's like masks. At first they weren't necessary and now they are. At first aerial spread wasn't thought to be a problem. Now we know that it can be. So I get it. It's a changing target. I understand all that.
Yep.
So schools had their focus where they thought it should be, but you're saying it's prudent for those school system managers to take a look at this and whether or not their filters can be changed and upgraded. Are they expensive? Is this costly for schools to do?
It is. And it's a relative term. It's not costly along the lines of replacing systems, but just looking at it, I think typical filters that they're using and this is just a rough estimate, but from a square footage cost might be in the 3 to 5 cents per square foot for the building cost. If you look, so that MERV 6 to MERV 8 range, if you look at something like a MERV 13 or 14, it might be in the 15 cents a square foot range. And again, these are just rough estimates I put together based on some pricing and some assumptions about a typical school that are certainly not valid everywhere, but 3 to 4 times as much for filters for the higher efficiency filters than it would be for the standard.
But we're not talking millions of dollars here, so it's an absorbable cost given the potential benefit. If those filters can reduce, what did I read, 85 to 90% of the circulating virus? Is that correct?
Yeah, the difference between a MERV 8 filter and a MERV 13 or 14 filter can be as much as 3 times or more the efficiency in removal of airborne particulate at the size range that we would expect those viral particles to be coming through the system at. So there's definitely a significant reduction.
What about room-sized HEPA filters? So HEPA filters are even more efficient than the MERV 14s you mentioned. Is it practical to assume I can put one of those in a classroom or an office building and have any positive impact?
That's a great question. And the answer, I think, is yes. So in our guidance, we have recommended if you can't achieve that MERV 13 minimum that we're recommending to target, or if you have other challenges, it's certainly advisable to consider some local filtration devices. And we've recommended using HEPA as a minimum for those devices. There are considerations that need to be made. If you have a central system or a local system that's distributing air through the room, you want to make sure that you don't interrupt that airflow or create an impact that might worsen the air distribution in the space. We also want to consider sound power levels for that equipment, because while it may be very effective at removing airborne particles, if it's loud enough that it prevents the function of the space from occurring. In the case of a classroom, if students can't hear the teacher over the noise that's being generated, I think it's likely that you'll see those units either get turned down or turned off, and then they won't be obviously as effective.
From what you know, does it, this gets into the weeds a little bit, but from what you know about how the virus travels through the air, is it practical that you could run those in-room HEPA filters when the school is unoccupied overnight? Would that make a difference, or by then is the virus already settled out and not a problem?
No, that's a great question. So we actually recommend, and not to steer away from your question, but just briefly, we recommend purging the building pre-occupancy and post-occupancy to try to get airborne viral particles out, try to get as much clean air in the space as we can before occupants come in, and then get any airborne viral particles out after occupants leave, because we don't know exactly how long those particles stay in the air or exactly how long they're viable from an infectious or an infectivity perspective. So running the filtration units after the space is empty, in fact, maybe turning them up, certainly not a bad idea. The thing we want to make sure of is that no one's expecting that doing that overnight and then shutting the units off during the day will make the space safe. The reality is the sources that we're concerned about are the people coming into the space. And so overnight, we're not going to build up a high concentration of viral particles. We may be able to remove it from the space, but the next day, if the systems aren't running, you run the risk of having that get built up again while the occupants are in space.
Yeah, I get it. No easy answers on this one. Another strategy is to kill the virus rather than just trap it or filter it away. And I've been reading about a special type of ultraviolet light. We are all aware of sunscreens that protect us from UVA and UVB, but there's a different type of sunlight or ultraviolet light called UVC that is germicidal. It kills the virus and bacteria. So what real-world evidence do we have about that, and is it effective to add that UVC lighting in our HVAC system?
Yeah, there's significant research that's been done, and this, in fact, has been done for 100 years or more in different ways to prevent transmission of bacteria or other contaminants of concern. It can certainly be added, and there are generally this type of application has been looked at cooling coils to keep them clean, but then also has the added benefit of being able to deactivate viral particles or kill bacteria. It needs to be considered carefully how it's applied. That UVC can damage other components in a system. It's obviously a safety concern for occupants. It can damage your eyes, or with longer exposure, potentially other.
Yeah, but you're saying that if that would be direct exposure to the light. So the UVC
Yeah.
light inside an air handling system, no threat to humans, right? I mean,
Correct. That's right.
Get that straight. So how effective is that UVC? And I would assume if I'm going to kill that virus, I'm going to kill the flu and other stuff as well. So we're talking about a general improvement in air quality, right?
Yeah, that's likely. What happens is we have to look at the intensity of the UVC light source that exists, and then we also have to look at air velocities in the system and the spacing that can be developed to get that into a system. So it may vary. I mean, there may be systems where single pass, complete or near complete destruction of the virus is possible. In many systems, it may be a percentage of the virus that can be deactivated. But if that's combined with filtration and outside air, there may be dramatic reductions in the amount of viral particles that could be recirculated.
If this stuff has been around for over 100 years, is the cost reasonable? Are we talking huge amounts of expense for a school system to install something like this in a building? I know there's so many variables you have to take into account there.
Sure.
Generally, is it crazy expensive or a manageable cost?
I think it's generally a manageable cost. Again, it depends on the type of system that's being utilized in a facility. If you've got terminal equipment that it has to go into, the cost may become very significant. If you have 2 or 3 air handling units, from a relative perspective, it's likely much more feasible.
Okay. Terminal being one big system, I am assuming then?
Terminal being smaller units distributed through a facility. So water source heat pumps that serve each classroom, or fan coil units, or unit ventilators. There are numerous types of equipment that can be, so where most of the heating and cooling is done at the classroom space or at the terminal space, and there may just be ventilation air coming from the center of the.
So if the actual heating and cooling happens at the room level or in the modular level, that's going to be a different expense than if you're heating and cooling all the air in the building. Right. That makes sense.
Yep.
What is your group's advice to parents or employees who are concerned and want to try to improve the quality of air in their buildings, not only for this virus, but for general health matters as well? What should we be doing about this?
Sure. I think our guidance document is available online for anyone that would like to review it. What we're really focused on in that document is, I guess the foundation of that document is getting back to good design principles for spaces in general. Many of these the intent is that they maintain good indoor air quality or good indoor environmental quality throughout those spaces at any time, regardless of whether there's a pandemic or not. So getting adequate ventilation in spaces, getting good filtration in spaces, getting good air distribution in spaces, being able to maintain temperature and humidity effectively in spaces. All of those are things that we recommend. In particular for schools, there are other added benefits that go along with that don't relate to transmission of airborne pathogens, but things like performance for students can be improved with better indoor air quality and more ventilation.
I'll tell you what, studying this has taught me that your world involves a lot of big science. There's a lot of math, a lot of volumetric calculations, and other crazy stuff that goes on as you design an air handling system, something I really didn't appreciate until today.
I find them to be interesting. I'm not sure if everyone does, but there's a lot to consider for every building, and each one is different.
I think if folks want more information, I would direct you to the ashray.org website. I'll have links in the description below. And Corey, thanks for joining us today and helping people understand what we can do to improve the air quality in our buildings and hopefully knock down some of this COVID-19 virus.
My pleasure. Thank you.